The root test can be used to help us determine whether or not a series is absolutely convergent. This test is helpful when we're dealing with series that have nth powers. The rules will be similar to the rules we saw with the ratio test. If our limit is less than 1, then the series is absolutely convergent. Notice this time we don't have a ratio, we're just dealing with the series a sub n. If our limit is greater than 1, then the series diverges. And if the limit is equal to 1, similar to the ratio test when we got a limit equals 1, the test is inconclusive, which means a sub n may diverge or converge. We don't know without additional testing. In this example, we'll use the root test. Notice that we're dealing with a series with an nth power. That's a good indication that the root test is going to be helpful. Limit n approaches infinity, nth root of the absolute value of n squared plus 1 divided by 2n squared plus 1 to the n. We'll copy the limit. Notice that the nth root and the nth power will essentially cancel each other, leaving us with n squared plus 1 divided by 2n squared plus 1. Now we simply have a limit at infinity. We'll divide the numerator and denominator by n squared. That is the highest power of n that occurs in the denominator. Limit n approaches infinity. 1 plus 1 over n squared divided by 2 plus 1 over n squared. Now evaluating the limit, we get 1 plus 0 divided by 2 plus 0, or 1/2. Note that that limit is less than 1. So, by the root test, we know that the series that we started with is absolutely convergent. And if we know it's absolutely convergent, we can also say it's convergent. In this example, we again want to use the root test. The limit as n approaches infinity of the nth root of the absolute value of negative 2n divided by n plus 1 raised to the 5n. Notice that the nth root and the nth power will undo each other, leaving us with the limit as n approaches infinity of the absolute value negative 2n divided by n plus 1 to the 5th. At this point, notice we have negative 2 to the 5th power. That's negative 32, and it's inside the absolute value. So that's really positive 32. Since that's a constant, let's pull it out front so we can focus on the n's. We now have n divided by n plus 1 to the 5th. Next, let's divide the denominator by n and the numerator by n. We have 32, limit. In the numerator we get 1, in the denominator we get 1 plus 1 over n. All of that is to the 5th. Now evaluating the limit, we get 32 times 1 plus 1 plus 0 to the 5th, which is 32. Since that number is bigger than 1, by the root test, we can say that the series negative 2n divided by n plus 1 raised to the 5n diverges.